Good afternoon. Today we will learn section 7.9. Okay, so we will write definite integral by substitution method. In substitution method, what we do, we change the variable from x to another variable and then integrate in indefinite case. But there is a change when we use the substitution method in definite integral, is that now there is a lower limit and upper limit, so we have to also change the lower limit and upper limit according to the new variable. So when we have to evaluate the definite integral from a to b fx dx by substitution, then we follow the following steps. In step 1, we consider the integral without limit, like we have to integrate in indefinite case. Okay, and we substitute the some function fx as y, that is we change the variable to another variable. We take a new variable y and convert the function of x into y and integrate the new integral with respect to that new variable and without mentioning the constant of integration, and then resubstitute for the new variable and write the answer in terms of original variable. And then we apply the second fundamental theorem of integral calculus and find the value of definite integral. So at first substitute by convert the given variable into another variable so that it reduced to an integral of known form, and then in second step we integrate and find the indefinite integral without mentioning the constant of integration, that is antiderivative. In third, resubstitute the new variable in terms of original variable and then find the value of definite integral by using of second fundamental theorem of integral calculus, that is difference of values at the upper and lower limit of antiderivative. Okay, for example, we have to integrate definite integral from -1 to 1 5x4 under integration under square root x5 plus 1 dx. So here at first we choose which function we have to take as another, that is if we want to we take x4 as another variable, then convert the entire integral into the form of another variable and then integrate and find the value of definite integral by using the second fundamental of theorem of integral. Just try. Okay, so we need to find definite integral from -1 to 1 5x4 under square root x5 plus 1 dx. Here the lower limit is -1 and upper limit is 1. Now we use the substitution method to find the value of antiderivative. So we just put t is equal to x to the power 5 plus 1. We take the new variable as t, and now we convert the entire integral into the variable of t. So we have to write x in t format, and for the value of dx we also write in the variable of t. So we take x5 plus 1 as t, because when we differentiate it with respect to x we get dt is equal to 5x4 into dx, because integration of x to the power n is n into x to the power n minus 1. So when we differentiate we get dt is equal to 5x to the power 4 dx. Okay, we take x to the power 5 plus 1 as t because we can see in the question is that when we differentiate we get the value 5x4 and 5 into x to the power 4 already present in the question. So we can substitute 5 into x to the power 4 into dx as dt. So therefore my integral is converted into integration of root under t for x to the power 5 plus 1, we substitute t, and for 5 into x to the power 4 dx, we take it as dt. So my entire integral from the variable x, it converted to variable t. So we choose for substitution that part for which the differentiation is present in the integration, so that when we convert into another variable, the entire integral is converted to that variable. Okay, so we have to integrate integration of square root t dt, and we know when we integrate integration of x to the power n, we get x to the power n plus 1 by n plus 1. Here the value of n is 1 by 2, so we get t to the power 1 by 2 plus 1, that is 3 by 2, by 1 plus 1 by 2, that is 3 by 2, and so we get 2 by 3 into t to the power 3 by 2. Okay, this is the first step. Now we convert the into the original variable, that is for t we substitute back x to the power 5 plus 1, so we get 2 by 3 into x to the power 5 plus 1 power 3 by 2. Okay, this is the value of antiderivative. Now second step is complete. So hence integral of minus 1 to 1 5x4 under square root x to the power 5 plus 1 dx become 2 by 3 x to the power 5 plus 1 the whole power 3 by 2. Now we have to find the value of this at the point minus 1 and at the point 1, and apply the second fundamental theorem of integral calculus. We get the value that the value of this function to the power 2 by 3 x to the power 5 plus 1 whole power 3 by 2 at 1 minus value of the same function at point minus 1. So when we substitute 1 and minus 1 and subtract, we get the value of definite integral, that is 2 by 3 into 2 to the power 3 by 2 minus 0 is equal to 2 by 3 into 2 root 2, that is 4 root 2 by 3. So therefore the value of definite integral is 4 root 2 by 3. So when we have to evaluate definite integral by substitution method, at first step we have to choose a function such that we can put into another variable, like we have to choose here x into x to the power 5 plus 1 as t. We choose in such a way that a differentiation is present in that quotient, or we can transform into the form of the new variable t. So we can write here 5 into x to the power 4 dx as dt. So my entire integral is converted into the integration of root under t dt. Okay, and then we apply the same process, find the value of antiderivative, and apply the second fundamental theorem of integral calculus to find the value of definite integral. Okay. There is another method. Alternatively, we can also transform the integral and evaluate the transform integral with new limits. That is, in the last case, we don't need to change our limits. That is, lower limit is minus 1 and upper limit is 1. But in case of substitution method, we can also use this method to find the definite integral directly. We don't need to substitute back into the original variable. We can directly find the value of definite integral by the new variable, that is t. So let t is equal to x to the power 5 plus 1. So dt is equal to differentiate with respect to x. We get 5 into x to the power 4 dx. Now there is another step. New step is that we have to find the value of upper limit and lower limit with respect to new variable. So when x is equal to minus 1, that is the value of lower limit is minus 1, the value of t is just substitute in place of x to the power 5 plus 1 minus 1. So minus 1 to the power 5 plus 1. So minus 1 plus 1 it become 0. Okay. And when x is equal to 1, that is the value of upper limit, just put x is equal to 1 in the value of t, we get 1 to the power 5 plus 1, that is 1 plus 1, so 2. So here is the new step is that Now we convert the value of upper and lower limit into the with respect to the new variable t. Okay, so in this case, the step where we have to substitute back the value of new variable with respect to original variable, that is old variable, we don't need. We directly find the value of definite integral with respect to our new variable. Okay, so when x varies from -1 to 1, that is the value of change from -1 to 1, t varies from 0 to 2. So now my definite integral become from 0 to 2 under square root t dt. So the value of -1 to 1 integration 5x4 5 into x to the power 4 under square root x to the power 5 plus 1 dx, it become integration from 0 to 2 under square root t dt. So by using substitution method, we convert our integral into easier form. Okay, and now we don't need to substitute back the value of t in x, because we also convert our limit from old value to the value with respect to the value t. Okay, so when we integrate, integration of under root t is, apply the standard formula of tn, we get 2 by 3 into t to the power 3 by 2. Now apply the second fundamental theorem of calculus, that is find the value at upper limit and lower limit. The upper limit is 2 and lower limit is 0. So substitute in place of t at first 2 and then subtract and then put 0. So we get 2 by 3 into 2 root 2 minus 0, that is become 4 root 2 by 3. That is same answer as in previously we find. So in alternatively case, what we do, we just take another variable and convert our definite integral with respect to that new variable, and also change our upper and lower limit value with respect to that new variable, and directly find the value of definite integral. We don't need to substitute back the value of t. Okay, so therefore the value of definite integral is 4 into root 2 by 3. The whole process is same as indefinite integral. As we use substitution method in indefinite integral case, there is the only one difference is that first change your upper limit and lower limit value with respect to new variable, and the second change is that for find the value of definite integral value, apply the second fundamental theorem of integral calculus. Okay, now the second example we have to find the definite integral value of definite integral from 0 to 1 tan inverse x by 1 plus x square. Okay, so which block we should have taken as to substitute it as new variable, so that the differentiation is present in that question, that is in integrand, so that it directly completely converted into a format of new variable, where we apply the second fundamental theorem of calculus and find the value of definite integral. Just try to solve. Okay, so here we take tan inverse x as t. We take it as t because when we differentiate it with respect to x, we get dt is equal to 1 by 1 plus x square dx, that is present in our integrand. So what if we take t is equal to 1 by 1 plus x square dx? Then when we differentiate it, we don't get in the format such that it converted into that variable. So we choose we choose t is equal to 10 inverse x because there is present 1 by 1 plus x square into the integrand. Okay, so the first step is complete. We differentiate, we get 1 by 1 plus x square dx. Now we have to convert our upper limit and lower limit with respect to new variable t. So when x is equal to 0, the value of 10 inverse 0 is 0. So t is equal to 0. And when x is equal to 1, that is when upper limit is 1, with respect to t, we just the value of 10 inverse 1 is pi by 4. So x varies from 0 to 1 and t varies from 0 to pi by 4. Therefore, my integral become 0 to pi by 4. In place of 10 inverse x, we substitute it as t, and for 1 by 1 plus x square dx, we put dt. So my integrand become 0 to pi by 4 t dt. So now we apply the standard formula of integration. There is a misprint. So it become equal to t square by 2 from 0 to pi by 4. Okay. So now apply the second fundamental theorem. At first put in place of t pi by 4, then minus 0. So it become 1 by 2 pi square by 16 minus 0. So that is pi square by 32. And that is the value of definite integral. Okay. So we can use substitution method to find the value of definite integral. Now we do exercise 7.9. So the first question is evaluate the integral using substitution, and from that is the definite integral from 0 to 1 x by x square plus 1 dx. So at first, the first step is we have to choose the new variable. Just like if we can take x is equal to t, or we can take x square plus 1 is equal to t, but we chosen in such a way that when we differentiate it, the differentiating value is also present in that integrand, so that we can convert the entire integral into that with respect to that new variable. Okay. And in the second step, we also have to find the value of upper limit and lower limit with respect to that new variable, and then we integrate to find the value of antiderivative and apply the second fundamental theorem to find the value of definite integral. So you try. Answer is 1 by 2 log 2. Let's see detailed solution. So when we have to evaluate the definite integral from 0 to 1 x by x square plus 1 dx, we use the method of substitution. So we choose x square plus 1 as new variable, that is t is equal to x square plus 1. Why we choose? Because when we differentiate it with respect to x, we get dt is equal to 2x dx, and that is a constant multiplication of the numerator x. So we can convert x dx as in dt. So when we differentiate with respect to x, we get dt by dx is equal to 2x. So dt is equal to 2x dx. So from this we can see that we can write ax dx as 1 by 2 dt. So now in second step we have to find the limit of integration with respect to new variable. So when lower limit, that is x is equal to 0, t is equal to x square plus 1, that is 0 square plus 1, that is 0 plus 1. So t is equal to 1. When that upper limit is 1, so t is equal to 1 square plus 1, that is 2. So my x varies from 0 to 1, but t varies from 1 to 2. So my entire integration of definite integral from 0 to 1 x by x square plus 1 dx using substitution method, it converted to from t is equal to 1 to t is equal to 2, 1 by t into 1 by 2 dt. In place of x dx, we write 1 by 2 dt, and in place of x square plus 1 we write t. So my integration become from 1 to 2 1 by t into 1 by 2 dt. Take the constant outside the integral, we get 1 by 2 integration of 1 to 2 1 by t dt. Okay, so now we integrate with respect to t. As we know, the integration of 1 by u du is log u, so it become log t. So 1 by 2 square bracket log t 1 to 2. Now apply the limit of integration by fundamental theorem of calculus. We get 1 by 2 log 2 minus log 1. This is the way to write fundamental theorem of calculus, that is 1 by 2 square log t from 1 to 2. It's mean we have to find the value of log t for upper limit and then subtract the lower limit from that value of upper limit. So we get log 2 minus log 1. So now apply since log 1 is 0, so we get 1 by 2 log 2, that is the value of definite integral. So to use the substitution method in definite integral, the main problem is which function by which block we should take as a new variable so that my entire integral is converted to the new variable. And then always remember to convert your limit upper and lower value with respect to that new variable. And then we just need to find the value of antiderivative and apply the second fundamental theorem of integral calculus to find the value of definite integral. So important part is substitution. So in this question we have to integrate the definite integral from 0 to pi by 2 under square root sine phi cos the power 5 phi d phi. So just think. So the answer is 64 by 231. Okay. So we use substitution to simplify the integrand. Now the key is the notice that we have sine phi under a square root, and cos phi rise to an odd power, that is cos the power 5 phi d phi. So we choose sin phi as new variable t. Okay, why? Because when we differentiate sin phi with respect to phi, we get dt is equal to cos phi d phi, and in the integrand there is cos phi, for which we can write cos phi d phi as dt. Okay, so that my entire integral converted with respect to new variable. So let's consider I is equal to 0 to pi by 2 under square root sin phi into cos the power 5 phi d phi. So at first rewrite cos the power 5 phi as cos the power 4 phi into cos phi. Why? So that we can write cos phi d phi as dt. Okay. So for cos the power 4 phi, we can write in terms of sin phi using the Pythagorean identity. We know cos square phi is 1 minus sin square phi. So cos the power 4 phi, that is cos square phi whole square, it become 1 minus sin square phi whole square. Because we know we can write sin phi as t. But for cos phi, we have to convert into the form of sine, so that my integral converted with respect to new variable. So substitute this back into the integral. The now perform the substitution. T is equal to sin phi. When we differentiate both sides with respect to phi, to find dt, we get dt is equal to cos phi d phi, because differentiation of sin phi is cos phi. So when we see I is equal to 0 to pi by 2 under square root sin phi. So for sin phi, we take it as t, and for 1 minus sin square phi, we take it as 1 minus t square whole square, and for the block cos phi d phi, we take it as dt. So that my entire integral with respect to phi, it converted to the integration with respect to t. Okay, so now in the second step, we must also change the limit of integration from phi value to t value. So when the value of phi is 0, that is lower limit is 0, the value of t, that is sin t, so sin phi, so in place of phi just put 0, so t is equal to sin 0, and value of sin 0 is 0. For upper limit, that is phi is equal to pi by 2, so value of t is sin pi by 2, and the value of sin pi by 2 is 1. So my old variable varies from 0 to pi by 2, whereas my new variable varies from 0 to 1. Now substitute t and dt and the new limit into the integral. So I become 0 to 1, that is t is equal to 0 to t is equal to 1. In place of sin, we just substitute it as t, and for cos the power 4 phi, we convert it into the function of sine, so we get 1 minus t square whole square, and for cos phi d phi, we put dt. So my entire integration with respect to phi is now converted with respect to t. Also, we converted our limits with respect to new variable. Now expand the term 1 minus t square whole square. So apply the formula of a minus b whole square, that is 1 square minus 2 into 1 into t square plus t square whole square. So we get 1 minus 2t square plus t the power 4. Substitute this expression back into the integral. We get I is equal to 0 to 1 t the power 1 by 2 into 1 minus 2 t square plus t the power 4 dt. multiply t the power 1 by 2 with all terms, we get integration from 0 to 1 t the power 1 by 2 minus 2 into t the power 1 by 2 plus 2 plus t the power 1 by 2 plus 4 dt. Okay, so it become 0 to 1 t the power 1 by 2 minus 2 the power t the power 5 by 2 plus t the power 9 by 2. Now integrate each term using the power rule of integration, that is integration of x and dx is x the power n plus 1 by n plus 1. So apply this formula and integrate each term separately. We get t the power n plus 1, that is 1 by 2 plus 1 by n plus 1. Apply the same formula, we get t the power 3 by 2 by 3 by 2 minus 2 into t the power 5 by 2 plus 1, that is 7 by 2, and then t the power 9 by 2 plus 1, that is 11 by 2. So we get I is equal to 2 by 3 into t the power 3 by 2 minus 4 by 7 t the power 7 by 2 plus 2 the power 11 into t the power 11 by 2. And we write it in a square bracket format, and there is a also represent upper and lower limit. In the upper corner there is a upper limit, value of upper limit with respect to t, and we represent also the lower limit for the integral, that is 0. Now we apply the second fundamental theorem of calculus. So since each term has t rise to some power, so when we substitute t is equal to 0, the all term becomes 0. So we get I is equal to 2 the power 2 by 3 minus 4 by 7 plus 2 by 11 minus 0. Combine this factor, just simplify it. So the value of definite integral is 64 by 231. Okay. So in substitution method, most important thing is how we take the new variable. And then always remember to convert your upper limit and lower limit value with respect to that new variable. Question number 3 is evaluate the integral using substitution, the definite integral from 0 to 1 sine inverse 2x by 1 plus x square dx. Okay, so at first we use substitution method to convert it into with respect to new variable, and then find the value of definite integral. Try. So answer is pi by 2 minus log 2. So we don't know the integration of inverse trigonometry. So we use the trigonometric substitution to simplify the inverse trigonometry function, so that it converted into a integral where there is no inverse trigonometry function, such that we can integrate it. So let x is equal to tan theta. Then differentiate both sides with respect to theta to find dx. So dx by d theta is equal to d by d theta tan theta. And differentiation of tan theta is sec square theta. So my dx become sec square theta d theta. Okay. Now we change the limit of integration from x values to theta values. So when the value of x is 0, so tan theta is equal to 0. And tan theta is 0 for theta is equal to 0. And when x is equal to 1, tan theta is equal to 1. And the tangent, the angle value for which tan theta is 1, that is pi by 4. Tan pi by 4 is 1. So theta is equal to pi by 4. So my x varies from 0 to 1 and new variable theta varies from 0 to pi by 4. Substitute x is equal to tan theta into the argument of sine inverse. The argument of sine inverse is 2x by 1 plus x square. So in place of x, just substitute x is equal to tan theta. So it becomes sine inverse 2 tan theta by 1 plus tan square theta. And using the trigonometric identity, that is 2 tan theta by 1 plus tan square theta is equal to sine tan 2 theta. So if we know this trigonometric identity, we choose the variable x is equal to tan theta, because we know 2 into tan theta 1 by 2 into tan theta by 1 plus tan square theta is sine 2 theta. So when we write sine inverse sine 2 theta, for theta belongs to 0 to pi by 4, because the theta varies from 0 to pi by 4. So 2 theta varies from 2 theta lies in 0 to pi by 2. In this range, sine inverse sine y is y. We know by the inverse trigonometric function. So sine inverse sine 2 theta become 2 theta. So inverse function is gone. So now substitute this into the integral with new limit. We get I is equal to 0 to pi by 4 2 theta into sec square theta d theta. We remove the inverse trigonometric function by using the trigonometric substitution, that is, in place of x we take tan theta, and by using the trigonometric identity 2 tan theta by 1 plus tan square theta, that is sine 2 theta, we convert it as 2 theta into sec square theta d theta is the value of dx. And the new limit is 0 to pi by 4. So I is equal to 2 integration of 0 to pi by 4 theta sec square theta d theta. Now we have to integrate it to find the value of antiderivative, so that we can apply the second fundamental theorem of calculus, integral calculus. So as here there is a multiplication of two functions, theta and sec square theta. So we use integration by parts method to integrate integration theta sec square theta d theta. The formula by parts is integration of u dv is uv minus integration of v du. uv means u into integration of v, that is v, minus integration of v, that is integration of dv, into differentiation of u. So we apply the method of elet to choose the function u and dv. So according to elet rule, the algebraic function come first, then trigonometry. So we choose u is equal to theta and dv is equal to sec square theta d theta. So now we have to find the value of du and v. So to find du, we just differentiate u with respect to theta. So du by d theta is d theta by d theta. So du is equal to 1 d theta. And to find the value of v, we integrate dv. So integration of sec square theta is tan theta. So the value of v is tan theta. Now apply the integration by parts formula. Just substitute for u theta, for du d theta, and for v tan theta. So we get 2 square tan theta tan theta from 0 to pi by 4. Now we apply the definite integral upper limit and lower limit directly to find the value of definite integral. So we just write theta into tan theta and find the value from 0 to pi by 4. So lower limit is 0 and then upper limit is pi by 4. So minus, then we integrate from 0 to pi by 4. Lower limit 0, upper limit pi by 4, tan theta 1 d theta. So it becomes the integration of tan theta d theta is minus log cos theta. So I become 2 theta tan theta minus into minus log cos theta. We have to find from 0 to pi by 4. So it becomes 2 into theta tan theta plus log mod cos theta. Lower limit is 0 and upper limit is pi by 4. Now apply the limits of integration. So at first find the value of this at the point pi by 4 and at 0 and then subtract. So we get I is equal to 2 in place of theta. Just substitute pi by 4. So pi by 4 tan pi by 4 plus log cos pi by 4 and then minus and then substitute in place of theta lower limit, that is 0 into tan 0 plus log cos 0. As we know, tan pi by 4 is 1, cos pi by 4 is 1 by root 2, cos 0 is 1 and log 1 is 0. Substitute this value, we get 2 into pi by 4 into 1 plus log mod 1 by root 2 minus 0 plus log 1. As the value of log 1 is 0, so we get I is equal to, using logarithmic property, log a the power b is b log a. So we get I is equal to 2 into pi by 4 minus 1 by 2 log 2. Distribute 2. We get I is equal to pi by 2 minus log 2. And that is the value of your definite integral. So in this question, my first problem is we have to apply the substitution method so that we can integrate this. But we don't know how to integrate the inverse trigonometry function. So we apply the trigonometric substitution method so that we can remove the inverse trigonometry part. Okay, and we use the identity, that is 2 tan theta by 1 plus tan square theta is sine 2 theta. So by this identity, we take x as tan theta. Okay, and that's how we convert my integral in such a way that inverse trigonometry part is removed. Okay. So next question is, evaluate the integral using substitution. The definite integral from 0 to 2 x into under square root x plus 2 dx. And there is a hint that we have to put x plus 2 as t square. That is your substitution variable. So just 2. Answer is 16 root 2 into root 2 plus 1 by 15. Okay. Let's do detailed solution. Now we have to integrate the definite integral from 0 to 2 x into under square root x plus 2 dx. So hint is we have to put x plus 2 as t square. That is, we take root under x plus t as t. From this substitution, we can express x in terms of t. That is, x is t square minus 2. So when we differentiate, x plus 2 is equal to t square with respect to x to find the value of dx in terms of dt, we get differentiation of x plus 2 with respect to x, that is 1, and differentiation of t square with respect to dx. So now we apply the chain rule. At first we differentiate the function, that is differentiation of t square, that is 2t, and then differentiate that function, that is dt by dx. Okay, so we apply the chain rule. So we get dx is equal to 2t dt. Now we change the limit of integration from x values to t value. So when x is equal to 0, t square is x plus 2, that is 0 plus 2, so t square is 2, so t is under root 2. Taking the positive root, since root under x plus t implies t is always greater than 0. Okay, so t is equal to root 2. Because square root is only defined if x plus t is greater than 0. Otherwise the function is not well defined and we cannot integrate it. So upper limit is when x is equal to 2, it becomes t square is equal to 4. So t is equal to 2. So my x varies from 0 to 2 and t varies from root 2 to 2. Now substitute x under root x plus 2 and dx and the new limits into the integral. So my integral become root 2 to 2. For x we substitute t square minus 2, and under root x plus 2 we substitute it as t square. So, and for dx 2t dt. Since t is greater than 0 in our integration, so we can write under square root t square as t. So we get integration from root 2 to 2 to t square minus 2 into t 2t dt. So I is equal to root 2 to 2 t square minus 2 t square dt. Expand the integrand by multiplying t square into the parenthesis. So I become 2 from root 2 to 2 t the power 4 minus 2 t square dt. Now using the power rule of integration, that is integration of t and dt is t the power n plus 1 by n plus 1. So my integration become 2 square bracket t the power n plus 1, that is 4 plus 1 by 4 plus 1 minus 2 into t the power 2 plus 1 by 2 plus 1, and then in a square bracket the upper value present the upper limit, that is 2, and the lower corner value present the lower limit value root 2. So when we simplify, we get I is equal to 2 into t the power 5 by 5 minus 2 into t cube by 3. So now apply the limit of integration. Fundamental theorem of calculus. We get I is equal to 2. First, write the value of t the power 5 by 5 minus 2 into t the power cube by 3 at point 2. And then find it at the value root 2 and subtract. So when we calculate the power, to the power 5 is 32, to the power cube is 8, root to the power 5 and root value is 1 by 2. So it become to the power 5 by 2. So we get 5 by 2 can be written as 2 plus 1 by 2, and we know to the power a plus b as 2 into a to the power a into to the power b. So it become to the power 2 into to the power 1 by 2, and the value of 2 square is 4, and to the power 1 by 2 can be written as under square root 2. So it become 4 into under square root 2. Similarly, when we calculate root to the power 3, it becomes to the power 3 by 2, and 3 by 2 can be written as 1 plus 1 by 2. Okay, so it becomes 2 into under square root 2. Substitute this value and just simplify it. So we find a common denominator of each pair of fraction. So we get I is equal to 2 into 32 into 3 minus 16 into 5 by 15 minus 4 root 2 into 3 minus 4 root 2 into 5 by 15, because common denominator is 15. So when we simplify, we get 16 by 15 minus 8 root 2 by 15. So I is equal to 2 into 16 plus 8 root 2 by 15. Distribute the 2, we get 2 into 16 is 32 and 8 into 2 is 16 root 2 by 15. Factor out 16, we get 16 into 2 root 2 by 15. So I is, the value of definite integral is 16 root 2 into root 2 plus 1 by 15. So now the question number 5 is, evaluate the integral using substitution from 0 to pi by 2 sin x by 1 plus cos square x dx. So we have to choose a function as new variable and convert the entire integral into with respect to that new variable, and then find the value of upper limit and lower limit with respect to that new variable, and then integrate and apply the second fundamental theorem of integral calculus. Okay. So answer is pi by 4. So when we use the method of substitution to find the value of definite integral, we take cos x as t, because when we differentiate it with respect to x, we know the differentiation of cos x is minus sin x, and that is a constant multiplication of numerator. So in place of sin x dx, we can write it in the terms of new variable t. So when we differentiate both sides with respect to x to find dt, we get dt by dx is equal to d by dx cos x. Differentiation of cos x is minus sin x. So multiply by dx to express dt in terms of dx. So when we multiply by dx, we get dt is equal to minus sin x dx. So from this, we can see that we can write sin x dx, numerator part of the integrand, as minus dt. And now it is crucial to change the limit of integration according to the new variable. So when the value of lower limit is x equal to 0, t is equal to cos x. So cos 0 is 1, so t is equal to 1. When the upper limit x is equal to pi by 2, the value of cos pi by 2 is 0, so t is equal to 0. So when x varies from 0 to pi by 2, my t varies from 1 to 0. Now substitute the t, dt and new limits into the integral. So integral become, in place of sin x dx, we substitute minus dt. Then by 1 plus, in place of cos, we substitute t. So it become minus dt by 1 plus t square. And the value of new limit, so t is equal to 1 to t is equal to 0. Now there is a property of definite integral is that when we find the value of definite integral from a to b fx dx is equal to minus b to a fx dx, just change the lower limit to upper limit and upper limit to lower limit. It gives the value of minus b to a fx dx. Okay. So the negative sign can be used to swap the limit, and there is a negative sign, and the limit varies from 1 to 0, 1 plus 1 by 1 plus t square dt. So when we use the property of definite integral, is converted into, we swap the limit, the negative sign gone, and it becomes 0 to 1, 1 by 1 plus t square dt. My lower limit is become upper limit, and my upper limit become is lower limit. Now integrate 1 by 1 plus t square with respect to t, and we know the integration of 1 by 1 plus t square dt is tan inverse t. So I is equal to square bracket tan inverse t. The upper corner value represent upper limit value and the lower corner value represent the value of lower limit. Now apply the limit of integration. Fundamental theorem of calculus, that is the value of antiderivative at the point of upper limit minus the value of the antiderivative at lower limit, and the value of antiderivative is tan inverse t. So I is equal to tan inverse 1 minus tan inverse 0. So the value of tan inverse 1 is pi by 4, since tan pi by 4 is 1, and tan inverse 0 is 0 since tan 0 is 0. Substitute this value. The value of definite integral is pi by 4. Okay, that's all for today. Okay, thank you. Try to solve the remaining question.